This is 7.3b of geometry. So there's a proof in your book if you want. We're just going to go through one of them. So we are going to prove that these triangles are similar. So remember, we've got three different ways to prove similar triangles. AA similarity, SSS similarity, and SAS similarity. Okay, so let's start with our two columns. Fill in our given. So MP is parallel to AC. That's given. Okay, so are we given anything about side lengths? We're not given anything, but we're not given anything about angles. But if you think about parallel lines have to do with angles, right? We've talked about alternate interior, alternate exterior, corresponding, same side interior, right? We talked about all those angles. So my guess is that we're not going to use the SSS similarity. Perhaps we can use the SAS similarity, but I don't think we're even going to be able to get two sides. But let's look at our picture. I'm thinking we need to think about angles. So first, hopefully you notice that these are vertical angles. So we can say that angle CBA is congruent to angle MBP. And that's vertical angles. Okay, so if we're going to go for angle-angle similarity, we just need one more pair of angles. And we haven't even used our given yet. So if you look at these parallel lines with this transversal, if you need to, tip your head, right, so you're used to seeing it. These right here are alternate interior angles. So since those lines are parallel, we know that those are congruent. So angle C is congruent to angle M by alternate interior angles. And then we've got the two angles are congruent, so now we can use our AA similarity to say that these triangles are similar. So triangle ABC is similar to triangle PBM by angle-angle similarity. And there you go. Okay, indirect measure, if you think about it like a flagpole or a cliff, some really big things that's kind of hard to get to, we don't want to have to use a measuring tape for that, right? That's just a little more difficult than we need to. How do you get it to the top of the flagpole, that kind of thing. So we can use indirect measurement to measure some of those things. One way you can do that is you can use a mirror. So when you use a mirror, when light bounces off, these angles are congruent, okay? They make congruent angles. So we can use that fact, as you'll see in this picture, to figure out big heights. So they placed a mirror right here in the middle, right? And they already marked that those angles are congruent. And we're going to try to measure this cliff face. So you can measure this distance, right? You just need to measure the ground. And you can measure this distance. And you'll know your height, right? So we've got these two congruent angles in the middle. But also, this is a right angle and this is a right angle. So these triangles are similar using AA similarity. So then we know that the triangles are similar. Then we can set up a proportion. So the height of the smaller triangle, 5.5, over the height of the big triangle, right? And that's just x, we don't know what that is yet, equals the base of the little triangle, 6, over the base of the big one, 34. And then we're going to cross multiply. So 5.5 times 34 gives us 187. And 6 times x gives us 6x. And when we divide both sides by 6, we get that x is equal to about 31.2 feet. Right, and then you got your height without having to attempt to measure that tall of a cliff. And there's your homework.